Good morning, children. This is your Vanaja madam, and today we will learn the third part of your lesson, playing with magnets. Before entering into the topic, just I want to recapitulate the last class. We learned about direction property of magnets, magnetic compass, uses of magnetic compass, unlike poles attract and like poles repel each other. That means the properties of the magnets we have learned. Today we will enter into a new topic, Earth as a magnet. Here a simple activity, children. I have placed a bar magnet. This one is a bar magnet which I have placed on the table. In any of the direction, whatever you want. Here it have been placed in this particular direction. This side showing the north and this side showing you the south. Now suspend another bar magnet over it as shown in this figure. And the suspended magnet should be little bit close to the one which you have kept on the table. Then if you see, first this suspended magnet move a little bit that side and this side, and afterwards it will come to rest, and the resting position will be always like this. Why it is like this means, as we all have learned in the last topic, unlike poles attract each other. Unlike poles attract each other. That's why the north pole have been placed on the side of south pole and the south pole have been placed on the side of the north pole. Now do one thing, the same activity, you reverse this. That means this side north pole and this side south pole you keep for the next time. And again you repeat the activity same. Again you can come to know this magnet which you have suspended also will be reversed in the position. That means unlike poles, to the unlike pole it will come near and it will get into the position. Here according to this magnet it will act. Okay, then already in the last class we have seen the direction property. Then about which magnet, based on which magnet it is coming into the north and south. That means yesterday we have seen the direction property. If you freely suspend a bar magnet, after some time it will come into the rest position showing the north pole of a magnet showing the geographical north and the south pole of a magnet showing the geographical south. Here what he is want to tell is, as this magnet will always depend upon the one more magnet which is there. Here earth will act as a magnet. That's why see here the earth which is there here, it starts acting as a magnet. And because of that the suspended magnet comes to rest in always north and south directions. Here earth is a very big magnet which is invisible for us. The earth possesses magnetic properties which acts upon the suspended bar magnet freely. That's why we will be getting like that. Freely suspended bar magnet will be always showing the geographical north and the geographical south. Now our next topic is finding out whether the given object is a magnet or not. In the last class also we have done an activity where we have seen which are magnets and which are non-magnetic materials. The substances which are struck to the magnets are said to be the magnetic materials. The substances which are not attracted or not struck to the magnet are said to be the non-magnetic materials. That one we have differentiated depending upon which type of material will be a magnetic material and which type will not be non-magnetic material. Here this is one more small activity showing, that means here what we will be doing is, we will bring an object. As I have told you, two poles will be there for the magnet. To both the poles, we will check whether both the poles are getting attracted or not, or both the poles are getting repelled or not. Based on that we will do this activity. See here in the observation table, if you see changes observed when brought close to one pole of a bar magnet for object 1, 2 and 3, and in the same way the second column is changes observed when brought close to another pole of a bar magnet. From these what we will conclude is, if an object is attracted by one pole and the bar magnet and repelled by another pole, then you can see it's a magnet. If any of the object is getting attracted to one pole of a bar magnet and it is getting repelled to the another pole, the same side of the object now you have to take. If you are doing like that, then you can say the object which you have taken is a magnet. If the object which you have taken is attracted by both the poles of a magnet, then you can't say it's a magnet. Just it's a magnetic substance. That's why it is getting attracted to both the poles. It is not getting repelled by any poles. That type of substances are said to be magnetic substances, but not magnets. If an object is getting attracted by one pole of a bar magnet and it is getting repelled by another pole, that type of objects are said to be magnets. If an object is getting attracted by both the poles, those are magnetic substances, not the magnets. And in the same way, if an object is neither attracted nor repelled by the magnet, means already we know it's a non-magnetic substance. That is the way how to find out whether the given object is a magnet or not, or a magnetic substance. That one you can find out by this simple activity. One more activity is there in your class here, that is make your own magnet. See here children, I have taken an iron nail. I have taken this iron nail and I have placed this on the table. Then you have to make sure that this nail don't have any magnetic property before. It don't attract any of the magnetic substances. And you take one bar magnet. See such that one pole of the side only you will be facing towards this nail. Place one pole of its near one edge of the nail. Without lifting the bar magnet, move it along the length of the iron nail till you reach the other end. Then lift the bar magnet, again bring it to the first end of the nail and move it along the length again as shown in the figure. Here in this figure they have given some arrows, see once here. That means this bar magnet must move like this. Again here you lift it up and again you have to take it here. You should not move like this back. If you are moving back, you are demagnetizing it. That's why this bar magnet, from where you are, whatever the pole which you are taking, either north or the south, it must be moved from top to bottom. Again you have to lift it back and again you have to start it from here. Like this you have to do 20 to 30 times. And afterwards, if you remove the magnet and if you take only this iron nail, it will start acting as a magnet. That is the way how to prepare your own magnet. And one more small activity, how to make our own magnetic compass. This is also a very small activity children. Take a magnetized needle. Here I have taken a needle, no, that one must be magnetized. How I have done in the earlier activity, how we have made our own magnet, in the same way you must magnetize one of the needle and you must fix it to the cork. This is the cork. For that cork you have to fix this needle, and which is a magnetized one, and let it float on a glass of water as shown in the figure. And add a little detergent or soap to the water to help this cork to float freely. This is the way how to make a magnetic compass. Here I have taken a magnetized needle. That means this needle I have magnetized by doing the previous activity which we have done. And we have taken this needle and we have taped it to the cork. And I made the cork to float on the water which is present in the glass. And afterwards, just for making it to float freely, just I have added a detergent, 2 to 3 drops of detergent to the water. Then the cork which you have taken will be floating freely, and this magnetized needle will start acting as a magnet by showing the north and south poles of the geographical north. That is the way how to prepare your own magnetic compass. Next part of the lesson is magnetic induction. This is very, very important children up to your 10th class. What is meant by magnetic induction? Before going to magnetic induction, I want to ask you what is meant by induction? Inducing something. Do you know the meaning of it? Inducing means something keeping inside it. Here I am inducing some subject into your brains. Did you understand? I am inducing something, some knowledge into your brains. That is said to be the induction. Here, see here a picture is there in front of you. A magnet is there. A safety pin is there. and an alpine is there. These are the three things which I have taken. For this magnet, what I will do is just I will bring a safety pin near to this magnet. Then you can see surely it will get attracted to it. Again, this alpine also I will take and I will bring near to the safety pin. I can see this also will be attracted because this magnetic power will be the magnetic power. That means its magnetic field will be up to somewhere. It will be spreading to up to some region, and that up to that particular region it will show its magnetic field. That means up to here its magnetic field will be there. That's why the objects it is able to induce. Leave for 10 to 15 minutes, and afterwards you do this one. You move away this bar magnet to a little bit distance. Now you can see this needle which is stuck to the safety pin will not get removed. Why? Because this magnetic bar magnet have induced the magnetism into the safety pin. This bar magnet have induced the magnetism into the safety pin. That means temporarily it will start acting as a magnet. After some time it will lose the magnetic induction which have been induced by this bar magnet, and again it will come back to its original position. That is said to be the magnetic induction. With this your lesson is finished, children. Now your work starts. Read the entire lesson. Again next Tuesday I think so we are having the class. Read the entire lesson. In this period 2 to 3 days, one day I will give you the ST like a revision or a ST question answers I will give. You can write it down in your book. Read your textbook line to line. Okay, children? Thank you. Have a nice day.